We've probably changed that into a bit of a tuner car for those that know. It's certainly a bit of a sleeper. Say a 520 horsepower model, you just reflash it and you add 150 horsepower. You add some ethanol to it, you add another 100 horsepower. You change the turbos and the stock internals and engine will do 1,000 horsepower.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Mitch and John from Dyno Spectrum. Dyno Spectrum is a company that specializes in offering tuning solutions for late model Audi vehicles. John and Mitch's specific skill sets are really focused on reverse engineering of factory engine management systems, which is a very specific and unique skill set. John and Mitch also both come from Cobb originally. That's where they actually met, and both have had a fairly long history in the automotive industry. John specifically cut his teeth on the early Mitsubishi and Subaru vehicles, specifically around open source, learning how to reverse engineer, decompile, and modify the factory code in those ECUs, specifically adding his own advanced features that never existed in that factory engine management system. Mitch, on the other hand, comes from companies such as AMS Peformance, who are no stranger to tuning both factory and aftermarket engine management systems. He then went on to Cobb, where he developed much of Cobb's Porsche platform for reflashing Porsche vehicles. Now, there's always the question that comes up here about when it's right to move from a factory engine management system to an aftermarket standalone. We dive into this question in a bit more detail with Mitch and John, but this, in my opinion, is becoming a more and more difficult question to answer. And specifically, we dive into the product that Mitch and John have developed for the Audi R8 and Lamborghini Huracan platform. And this really sounds like it is a rival to the big name players in the aftermarket standalone industry here on that platform, specifically both Motec as well as Cybex. Anyway, I don't want to spoil the entire interview for you, so we'll get into that shortly. But first, for those who are fresh to the podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune both factory and aftermarket engine management systems. We also cover performance engine building, wiring, race car setup, driver education, and data analysis, just to name a few of our topics. Relevant, of course, to today's topic, we're talking about engine tuning and specifically here, reflashing factory engine management systems. And we've got a range of courses that cover the information you need if you want to learn how to do exactly this. I'd suggest starting with our EFI Tuning Fundamentals course. As its name implies, this teaches you the fundamentals of aftermarket and factory engine management. Essentially how the ECU works, how fuel injection works, what we're trying to do when we're tuning the fuel tables, the ignition tables, etc. Once you've got that basic grounding, we also have our Understanding Air-Fuel Ratio course. We'll teach you what air-fuel ratio is, why it matters. We'll give you some safe starting air-fuel ratios for a range of different engines so you can get up and running with no danger of doing any damage. And then, most importantly, we'll teach you how to test and find the optimal air-fuel ratio for your particular application. And lastly, dealing with reflashing, we have our practical reflash tuning course, and this will teach you how to reflash on any tuning platform, open source or commercial. It doesn't matter. Also doesn't matter what type of vehicle you are tuning. And we know that when it comes to tuning your first car, can be a bit daunting knowing what to do first and what order to progress. Well, to break it down and make it simple, we've developed the HPA Six Step Process. And by doing this, each of those individual steps is quick and easy to complete. In no time, you've got an optimally tuned engine giving great power, great torque, great drivability, but most importantly, great engine reliability. You can find all of those courses at hpacademy.com/courses. We will put a link in the show notes to those 3 specific courses. And as a HPA Tuned In podcast listener, you can use the coupon code podcast75. That'll get you $75 off the purchase of your very first course. All right, enough with our introduction. Let's get into our interview now. All right, John and Mitch, welcome to the Tuned In podcast. Thanks for joining us. And I think probably the best place to get started is finding out a little bit about your backgrounds and how you got involved with tuning, reverse engineering, etc. Maybe, Mitch, if we just start with you, can you give us your sort of backstory?
I started doing calibration and reverse engineering. Well, calibration I've been doing for about 20 years. I started when I was around 20, and I slowly started with kind of standalones like AEMs. A lot of it was self-taught. There was no HP Academy. From there, I just kind of kept working and kept learning things, new systems. Then through that, stock ECUs kind of started to evolve, and more folks were starting to use stock ECUs as tuning mechanisms. So started doing that, ECUtech, open source stuff. I really did start with a lot of the Mitsubishi Evo and Subaru WRX and STI. And then through that, I've done quite a bit of stuff. I was a calibrator at AMS Peformance. For those that don't know, AMS has done a lot of amazing things. Big power, Evos, DSMs to the GTRs to now, the V10 Lamborghinis and R8s. But I was a calibrator there alongside Chris Black and Martin Musial. Learned a lot there. I was doing some reverse engineering there on the Porsche platform, mostly on the weekends, just because nobody could really tell us how to tune a European car on the stock ECU. That's probably where a lot of this kind of started. But from there, I was hired by Cobb to do some customer calibration, but that quickly turned into reverse engineering. So it turned into the kind of the lead engineer for the Porsche platform, the Porsche Access Port. So that was kind of, I started with that, did that for many years, and then started this, with John. So, John started it, but I joined in later. We had worked together at Cobb. We'd had some small overlap, but not a lot of interaction together until after we had actually left.
Okay, a bunch of interesting stuff there I want to go back and dive into, but before we do that, let's just bring John in. And John, I understand your path in this journey has been quite unusual because, as I understand, you trained and worked as a doctor, which is probably about as far removed from engine tuning and reverse engineering as you can get. So really interested to learn how that came about and more importantly, how you made that pivot towards the reverse engineering and engine tuning side of things.
My story started in the 80s as a child that enjoyed electronics and computing. And I was encouraged, what turned out ultimately unwisely into a career in medicine by various influences, teachers and so on, and ended up spending the 90s training to be a doctor. I didn't really discover cars until I'd graduated and, started to pay off a little bit of debt and got a job, and then happened across the Subaru Impreza Turbo. And at that point, I very quickly found that it wasn't fast enough. So I had then picked up my electronics again and started making fuel cup defenders, analog ones. Then I picked up a microcontroller and started, making them more sophisticated, and then made an electronic boost controller. And I was really enjoying this stuff, playing around in my own car and getting some good results. Then ECUtech in 2002 launched their first product, and we started talking, and I really wanted their product just so I could calibrate the ECU myself. But they encouraged me into making it a commercial thing. So I went to see them, got some training, took the product away, worked on my own car and developed it. And although I'd just become a partner in a medical practice after 9 years of training, I started running a business on the side, tuning Subarus in my evenings and weekends. That grew pretty quickly. I didn't have a dyno, I didn't have premises or anything like that, but it soon became very obvious that this business could expand into that. And it's at that point I made a crucial mistake by not taking that route. I continued in medicine because, people say you've put all this effort into this career, you can't throw it away. But although I functioned in that career, I didn't enjoy it. I didn't love it.
Okay.
And, that kept going.
There's got to be. I'm just interested to dive into that a little bit more. It sounds like there's a bit of a sunk cost fallacy sort of going on there, as you mentioned. You've invested so much time and undoubtedly a huge amount of money in that medical career. So I'm guessing, obviously not a doctor, but I'm guessing that medicine can be a very lucrative field, particularly once you've paid off all of your loans. So there's this trade-off here, yes, I can make some money, but this is definitely not a passion of mine anymore. I'm not really enjoying it, versus looking at what the automotive angle and the enjoyment you're getting out of that could potentially give you. Is that where you're sort of making that decision?
Yes, you're absolutely right about the sunk cost. And what happened subsequently is that I'd become a partner in a practice. I was running that, but from time to time, I would take on a new project. So the Subaru tuning business, I let come to an end. For a few years. I didn't do much. And then, although I say I didn't do much, I actually got through, I think, 10 different types of turbo, 5 different transmissions in my Subaru because I kept breaking them. Tried a 2.3, a 2.5, various forged and other engines to try and get more power. So the bug never left me. And then I changed to the Mitsubishi Evo, and all the lessons I'd learned tuning the Subaru, suddenly I was rewarded with reliability and more performance with the Evo. But that was at the time when open source came out, and you could suddenly flash the ECU and you had full access to its contents, but nobody had defined the maps. The logging was acceptable but slow, a factory protocol. So I started disassembling the ECU, changed the logging from 100 items a second to over 4,000, added some real-time tuning, made it speed density, changed the boost control, all that sort of thing.
You say sort of all that sort of thing and kind of just gloss over that like that's just something we can do in our sleep. But you've just talked about some pretty deep stuff here, and I just want to go back and Mitch, I'm not forgetting about you. We'll come back to you as well. You've actually mentioned some of the same stuff here with open source. And I mean, essentially, when I started doing factory engine management, it sounds like we kind of followed, at least at the start, a fairly similar path, in that Subaru and Mitsubishi was also my bread and butter, and their open source software that was available, that's what we were doing as well. So for those who aren't aware, John, can you just first of all define what do you mean by open source? What is that?
The definition's a bit vague because what people mean is different, but whilst the open source really means that the code is available and published for free on the internet, usually on a now repository like GitHub, so that people can collaborate and share it. Anyone can run it, anyone can see how it works, anyone can use it to learn from, develop, even make into commercial products, depending on the license. So Tactrix made a flasher and a cable that allowed Mitsubishi Evos and Subarus to be reprogrammed, and they added some table definitions, and a community grew up around them, which was very vibrant. So people started to, some of these ECUs you can read out. So they started reading out their Mitsubishi Evo maps and seeing that their timing tables are full of 8 degrees everywhere, for example. And they started to realize that they needed to use their enthusiasm and turn it into skill to tune themselves. And I think that improved the commercial tuners as well, because they had to up their game a little bit because their work could sometimes be inspected or logged. So that was the open source. What wasn't open source with Tactrix and hasn't been, to my understanding, since is the actual flashing isn't. And there's 1 or 2 people that do publish their actual flashing code, but mostly by open source, people mean you can read and write the contents of the ECU using relatively cheap equipment, and then you can alter it freely yourself.
Yeah, I think, as you mentioned, there's obviously various definitions. I always take it as the open source is essentially free or very cheaply available software, and in this case, the Tactrix hardware that we need is the interface between our ECU and the OBD2 port. Last time I checked, I think that's maybe under a couple of $100 US, so in the big scheme of things, really, really cheap. And then the flip side of this is we've got commercially available software, and you've both mentioned Ecutech and Cobb just as a couple of examples. There's obviously dozens, if not hundreds, of manufacturers out there where you're paying for the software and hardware that you're using. You're also paying potentially a license fee for every vehicle you tune, and obviously that's how the commercial software companies make it into a viable business. Now, on the open source front, we've got this community of enthusiasts that are developing the product and finding these definitions. And before we go further with this, because this can be problematic, at least in my experience, can Mitch maybe explain to us, what does that term definition actually mean? And why is that important when we download that raw binary file out of the ECU? What are we actually faced with? What's the definition help us with?
Yeah, so basically what you're looking for is, if you're downloading just a raw binary, you're downloading multiple parts of the ECU, parts of program code, parts of the calibration data. In order to make functional changes, you have to be able to define all parts of what's in there. You need to be able to define what is the program code, and also more importantly, how does that program code work? And ingrained within that program code is usually the calibration data. So you need to also be able to define the tables that you need to make changes to, say ignition timing or lambda, target lambda, idle control tables, etc. All those need to be defined and they need to be correct. It's actually quite easy to make mistakes in those definitions as you're taking basically hexadecimal and turning it into something that needs to be human readable and human editable. So it takes good care to make good definition files, and in the fact that you need to modify those, and making those incorrectly and flashing them back onto an ECU can cause damage to the engine, to the ECU, etc.
Yeah, absolutely. And I think probably it's important to sort of mention, I don't have exact numbers here. My guess is probably somewhere in the region of maybe 90 to 95% of tuners that are relying on open source reflashing software. And again, for the moment, let's just continue on the Subaru/Mitsubishi platforms, are probably relying on definitions that other people are creating and don't have the capability to actually modify or find their own maps. So there's two very different skills here. Now, at the start of my career, I was in that situation, and because here in New Zealand, we predominantly get the Japanese domestic market models for both Subaru and Mitsubishi, and there's subtle but important differences often between the JDM and the US domestic market models in terms of their definitions, because of course the dominant market is USDM, and that's where that user base is, the open source user base or community. The definitions, as I saw it for the USDM models, were usually pretty thorough and quite complete. And for a lot of the JDM models, there were whole maps missing. Maybe we didn't have a boost target map or a wastegate duty cycle map or something like that, or often the definitions would be scrambled. So you sort of go into an ignition map and the axes would be just absolute garbage, or the numbers just clearly you looked at them and they didn't make sense. So on that front, what's the jump in skill set required to go from actually just using a provided definition file to actually finding these maps, reverse engineering how the ECU works, and finding your own?
There's a couple of ways to do it, and the way that most people do it is through pattern recognition. And some of them then if they don't, for example, have any form of factory definition, they might be able to log something like ignition timing, and then they see things that look like ignition maps, or somebody else has told them that they start altering them, log the car. That can work if you've got a high and a low octane ignition map, an ignition map for where the valve time isn't working or something like that. But it falls over when you have multiple versions. So, for example, just on one engine on an Audi, there are 31 software versions, and that's just the up-to-date software versions. Some of those versions each have within them 8 or 10 updates over a number of years. And often what happens is that when the code is changed, the code is recompiled, even with small changes, and the maps can move around. They can change order, they can change size, they can change shape. And that's when pattern recognition and experimentation really is quite risky. So, for example, some of our platforms have, say, 96 ignition tables. And it's a bit of a nightmare for the tuner to know which one to alter. So you could try altering them all, but what if they've got different contents? You're implying and you're guessing. And so that's where disassembly comes in. And that's what I was really able to contribute to open source on the Evo 9. In the UK, I had effectively a JDM Evo 9. And I started disassembling it to improve the map definitions so I could give some certainty about the way things worked because I was looking at the code. And that's the crucial change that we've continued for 15 years since then, and what we hope differentiates the sort of thing we do because we understand the nuts and bolts behind the data because we're looking at the code.
If I'm understanding what you just said there correctly, rather than just the pattern recognition using software, that looks like a map. We'll dive into that. It's an ignition map, but we don't know. Maybe we've got, as you said, 30 plus, 96 plus ignition maps, whatever it may be. We don't know how, when, and why the ECU may use this map over this other map. Instead of just relying on that pattern recognition, you're actually going deep into how the ECU code works, basically the logic flow of how the ECU processes inputs and decides which table to use at any particular time. Is that, in a nutshell, have I got that about correct?
Yes, and I'll use any available data and experimentation, but if it takes me a month to work through 96 ignition tables that I can give the tuner 2 or 3 and tell them definitively when they work and tell them which ones they have to adjust, that's what I'll do because I don't try and take on lots of models. I'll spend 3 years on one sort of series of ECUs plus, whereas so I can specialize and offer that sort of detail that people want. And that really, really helps the tuner workload. It helps them to tune it more like a standalone because they've got some certainty in what they're doing.
So on that note there, I don't know if the example you gave is actually sort of a set in stone one, but 96 ignition maps, and you just sort of mentioned that the ECU may use 3 of them, and under what circumstances it does use those 3. Now, if that's the actual situation, it wasn't just sort of an anecdotal number that you gave me, why does the ECU have 93 other maps in there that it's not using? That's always interested me.
They can be used. Usually what happens is you get a couple of variants for fuel octane. So by the coding in the car, which can be coded in its EEPROM or emulated EEPROM for different regions, they can, without actually flashing the car differently, they can just say this is a low octane region. They can do coding for different exhaust types. So they can say that this is an OBD2 compliant North American region exhaust, and it might have an extra cat or a different silencer. They might have coding for another region where they've got a gasoline particulate filter. They might then, every time they add intake valve timing and then exhaust valve timing and then variable valve lift, every time they do any one of these things, you multiply up the number of tables. So you end up with 2 multiplied by 3 multiplied by 4 multiplied by 5, and then you get big numbers.
Sure. Okay.
So, for example, if they've got one for exhaust valve timing and the exhaust valve timing isn't working and it's not in position, it will switch to one of the others. And that can happen, for example, in cold conditions. So it could be freezing and the oil temperature is too low and it might just disable the variable valve timing and then it will suddenly use a different ignition map. Well, if you don't know that or you haven't tuned it or you've assumed, you could be in some trouble. You may also have a car like an R8 that you've turbocharged and there may be a minimum ignition timing maps and you might have taken degrees out of the ignition timing table to cope with giving it a bar of boost where it had none from the factory. And then in a certain circumstance, you could hit a minimum ignition timing table and it suddenly throws in far too much timing again. So you've really got to watch the edge and the corner cases. And that's what we feel quality is about, looking beyond the horizon so that you're really reducing all your risks by an order of magnitude so that you protect the engine as best as possible and get the best results in your calibration.
Yeah, absolutely. I couldn't agree more. I think the issue or what may scare a lot of aftermarket standalone tuners off with particularly the later models of factory engine management systems is, as we've kind of alluded to already and just touched on, they are incredibly complex with a lot of tables. And you may have a situation where you've run the car on the dyno, everything seems to be performing flawlessly, but maybe out in the wild, out in the real world, it runs into some circumstance where you couldn't replicate that on the dyno, and maybe, as you said there, your R8 situation hits a minimum timing sort of limit, and all of a sudden you've got too much timing, something similar to that. So I think that information and education for the tuner so that they can avoid those potential pitfalls, obviously that's critical. Before we go too deep, there's still a couple more things I wanted to sort of circle back to here, and this was John, from your original mention of how you just blitzed through the Evo open source part. You mentioned two more things that I'm interested in getting some feedback on, and I know these kind of segue into what you're doing now with Dyno Spectrum as well. But logging, particularly with factory engine management systems, the logging is so critical, because otherwise we're essentially blind to what the ECU is actually doing. So logging, and often multiple parameters, is really, really important. So we've got a bit of a glimpse into what the ECU is doing, whether it be on the road or on the dyno. So the problem, as I've seen it, is a lot of engine management systems, the logging rate is relatively low, and particularly when we start logging multiple parameters, which obviously is essential, as I just mentioned, that logging rate can drop down. And you just kind of touched on the fact that you were able to massively increase the logging rate. So can you talk to us about how that's done and why there's the limitations in the first place?
Okay. Most of the factory protocols are designed for diagnostics, not for calibration. And so they are slow, not particularly because your physical link to the ECU is slow. So even, say, a K-line, a serial line, basically on a Mitsubishi Evo, it might only offer you 100 parameters per second if you use the standard protocol. But as I mentioned earlier, you can get over 4,000. So that communications channel isn't contested by anything else. It's just going to the OBD port in that particular car. So what I was able to do with that is I read the processor manual, and I used a thing called DMA, direct memory access, where you can basically dump data to the serial ports, the K-line, without using the processor. So you're not taking up processor time doing this. You just steal a small fraction, and we're talking like, a fraction of 1% of the memory cycles on the ECU, and you fill up the K-line with good data. And you also do that not using the standard PIDs that come with the car, but you log RAM addresses. And so if you give a stack of 100 RAM addresses that you want to log as quickly as possible, or at 100 hertz, and we've even experimented in the lab at 1,000 hertz, but you just don't need that. It just gives you too much data. You can actually get a huge amount of data over a serial port. The 1,000 times a second is really over CAN bus. And then there are other technologies like FlexRay and Ethernet that can go even faster, that are in our near future. So really it is, I say just, but it is a case of software. If you change the code and you know what you're doing, you can write a new protocol or change an existing protocol and speed it up, and you can change its nature so that you're not limited to a standard set of PIDs.
Okay, that makes sense. I mean, the PIDs as well, often what we have access to, essentially, I'd say out of the box, can be quite limiting. So what I mean by that is we may not have access to some of the parameters that we really want to be able to see to help us with our tuning. So with that technique you've just mentioned there, I would assume that the key part is knowing the addresses for the parameters that you actually want to send at high speed over that K-line or whatever it is. Is that correct?
Yes, and we get those through disassembly. So as we disassemble the tables and you build up a picture of ignition tables, you then follow the route through and you find where the final ignition is before it goes out to the timers that fire the coils. And, you can log all the intermediate stages, for example. The first car we released for Dyno Spectrum, the 4-litre V8 twin turbo, there was no logging of wastegate duty. And so previously what tuners were doing was hooking up an Arduino to measure it and log it separately. So, that helped because you could suddenly get better boost control, but we could also log all the PID parameters and, watch the integrators move up and down, watch the adaptations go up and down. And so suddenly we were getting boost curves where, the boost would actually hit and hold the target. It would do it in every gear, every weather condition. And the cars are just so much smoother to drive. You control the intake temperatures better. You heat up the exhaust manifold and turbo too much. It's just smoother, it's safer, and it's a lot more OEM-like when you have that sort of quality of data.
It kind of makes for better diagnostics too, if I can jump in there too. So, at the end of the day too, just having high-speed data, just good data logging, period, it just adds for better diagnostics, helping customers down the road, because you can start to see faults earlier. You can start to see, when things have failed or maxed out or whatever. So us logging, a multitude of RAM addresses, and we'd log many hundreds of them, really helps us in the long run, helps everybody really.
Definitely. I'll just dive into that just a little bit for those who maybe, haven't really considered the logging frequency or logging rate. And often you might be limited, to use an extreme example, maybe you've got a parameter that you can only log at 4 hertz. So that's 4 samples every second. And that's an incredibly slow rate for something that might be moving quickly, maybe RPM, manifold pressure, mass airflow frequency, or whatever that may be. And if you don't, first of all, if you're not aware of that, what it means is that you're kind of blind to what's actually happened between 2 samples. And often your logging software is just going to draw a nice smooth line between the points that's actually logged, but you're really blind to what's actually happening between. So it can mask a lot of really, really important things. So the logging rate really is important to make sure that you're logging at a high enough frequency to actually see a true picture of what's going on. Obviously, not every parameter needs to be logged at 50 or 100 hertz. Air temperature or engine coolant temperature move relatively slowly, so it does depend on what you're looking at. But I kind of like to log, but most of the parameters between maybe 20 and 50 hertz. I think, as you mentioned, your 1,000 hertz probably a bit of overkill for most things, but it's nice to know that is a possibility. Just coming back to you, Mitch, we've sort of focused on John there for a little bit. I just want to circle back to some of your background. And when you were working at AMS Peformance, a big name for us as well here in New Zealand, back when we first started building drag cars, AMS were ones that we really looked up to and held at that time the late model Evo world record, which I was fortunate enough to have a customer come and want to try and take down that record. So AMS were really, and still are, working at the top of their game, particularly their alpha performance packages for the GTRs, the Audi, Lamborghini, etc., very well respected. Now, you mentioned that while you were working at AMS, you were sort of doing some Porsche reverse engineering in your own time. Sort of, how did that come about, and what was the challenges that presented for you? Sure.
So we were looking at kind of trying to do other things, that were kind of at the time sort of out of the box. It was Porsche performance, trying to understand how the Euro cars were done. And back then, I would say this was around 2007, there was no real guide to it. It was kind of this undisclosed black box that nobody wanted to give us access to. So we ended up doing a lot of research and, went back and started to find out these things that were kind of hidden. They're not so hidden now, but figuring out that, what was then Deimos files, but Deimos, you needed Deimos files, and you needed to get tools that could flash ECUs and things like that. And then it was more of a starting to break down, get tables discovered, understand them. And this is before my run in IDA, which is the software we use to decompile code. So it was a lot of trial and error. We definitely have some funny stories that weren't so funny back then, but he's probably laughing about now. But there's a lot of testing and just a lot of trying to understand, how does a VTG controller work inside of a turbocharger? And, that was very foreign and still is foreign to a lot of folks and turbo manufacturers. Really trying to understand a different model, so to speak, especially coming from JDM cars where, things are a lot different. They're using a different processor, a lot more, SH style stuff in terms of like the processor. So it's just a lot different control strategy methods and trying to understand those things.
Let's just talk about that for a moment. So the processor drives the the control strategy, or does the manufacturer choose a processor that they're going to build an ECU from, and then on top of that they've got their own sort of desired control strategy? How does that work?
So it's kind of different, it seems, for a lot of manufacturers. For a lot of the European manufacturers, a lot of them use Bosch ECUs. A lot of the processors are the same. What ends up kind of happening is that the manufacturers will decide certain things that they want put in the ECUs. So let's say Porsche needs VTG control over the turbochargers, so that's not a standard deal. Whereas Volkswagen may need something completely standard, but they can still use the same processor, same ECU. So it could be, an MED 17, and both could have tri-core processors, but they might be kind of wildly different in terms of some of the mapping, a decent amount of the code. So a lot of that stuff can change and does change between manufacturers. It'd be actually quite unusual if it didn't.
On that note, though, while you say, okay, Porsche want the VTG control strategy that Volkswagen don't need, maybe they're both on the Bosch MED, whatever generation it is the core principle of engine operation broadly similar between the likes of, you've used Porsche and Volkswagen as two examples, or, chalk and cheese, basically they may as well be two completely different controllers?
I mean, it's kind of a vague answer, I guess, is that they can be very similar. They can also be very different. It depends on a lot of things. Like if you had an ME7 ECU in like a Porsche, which comes in like the 996, 997, and then you compare that to MED 17, it can be similar. It can be different. Another thing Porsche did, which does make the control strategy completely different, is in the move from 997.1 turbo to say 997.2 or even 991, they switched manufacturers and went from Bosch to Continental. So all of a sudden, between two manufacturers, the control strategies are completely different. Naming conventions, everything, code is completely different.
So I guess for the Porsche tuners out there who were up to speed on the Bosch product, you kind of, over a generation change, had to relearn and start from scratch on the Continental platform. Is that correct?
Yeah, more or less, especially on the flashing strategy, on how you actually flash the car. But yeah, I mean, all the naming conventions, everything completely changed. So yeah, it was quite a big change.
Now, a moment ago, you used the term DAMOS, and that's something we hear thrown around in OE reflashing or reverse engineering terms. A2L is another one. Can you tell us what those terms mean and what the relevance of those is?
Yeah, absolutely. So DAMOS is, I use the word DAMOS. DAMOS is a pretty old name. It was kind of for what I would consider older ME series cars like ME7s. A2L is really a more common name. Really what an A2L is it's a factory definition file that is usually followed with like an S19 or hex file. It basically tells you for that one software version, basically what all maps are, what the RAM addresses are, and which is great. But that only does so much, because without understanding how the code works, you may know the 96 tables names and the addresses for them. But if you don't know how the code works and you've got to apply that to 20 other versions and they're all shifted and it's all different, the RAM addresses usually go out the window, and all of a sudden you've got to define a lot of things. So it makes things a lot more difficult. But yeah, it's basically just factory definition files from the manufacturers.
Okay, so definition, where the maps are, but not necessary from the A2L file, what the processor logic essentially is on how it's going to use the inputs, etc., to work out which map to use. The A2L file, the DAMOS file, I'm guessing that this isn't something that the factory is just handing out willy-nilly to the aftermarket. How does it come to be that we get access to these?
Old Navy buddies.
So a bit of a black market, and enough said, pretty much.
It's pretty gray,
Okay.
But yeah, I mean, to be fair, like there is some stuff floating around in various forums and, different automotive groups. So they can be found. Some of them were relevant or newer stuff is usually a lot harder to come by, and that is really where it gets a little gray.
All right, let's move sort of more into the process. I mean, we've obviously talked a little bit about this already, but the actual process that you both use for reverse engineering, you've got a controller that maybe you've got no previous experience with. Can you talk us through, first of all, the tools and software that are required, and then on top of that, how you actually go about reverse engineering that ECU, finding and defining the maps, and then validating the operation?
We use IDA Pro or IDA Pro, which is a common disassembler tool which covers probably now well over 100 different processor families. And so, for example, the SH2, I think, was related to something in a Sega Dreamcast in the 1990s or something, and then ended up in the Mitsubishi Evo and the Subaru. And the interesting thing for me with that was once I'd learned that, it did take me a while to learn and get good at that processor, because you're looking at compiled code that's got no hints in it. And you, as you disassemble it, you label things and you help the disassembler to find cross-references between tables and RAM addresses, and you gradually build up a picture and you piece it together. But it does take me quite a time to develop on one processor. And so I tried to stick to that for a couple of years in one ECU family. And that also has a relevance commercially for me, because I'd done the Subaru tuning and then let that go. And then the Evo work in the noughties was open source. I then got one of the earliest R35 GTRs in the UK in 2009. And that was when I came into contact with Cobb and got their access port. And they could already flash it. But when I tried to tune it, I found that the product wasn't quite formed in terms of things like knock control and logging of knock and wastegate control, for example. So interestingly, it had the same SH2 processor that I'd just spent 4 years on the Evo with, where I'd done the fast logging, the speed density, and all the other stuff that we mentioned. So I approached Trey Cobb and said, would you like me to do all of this for the GTR? And, I did a 3-year gig with them, still working as a doctor, and did all of that for the GTR. And that was really good fun. But after 3 years, I was struggling a bit with time and sanity, moonlighting 2 jobs, and I was paying locums to run my medical practice for a day or 2 a week so I could have more time writing stuff for the GTR. But that was a really, really enjoyable project. But yeah, again, I made the wrong decision then in 2012 by, retreating back to my medical career for a break for a while. And that lasted another 3 years until I finally burnt out the medical career and decided to do this really full time.
I guess that's probably a good segue into Dyno Spectrum, which is the business that you, John, and Mitch are running together and founded. So give us the sort of 30,000 foot view of what Dyno Spectrum is. What products and services are you offering?
So with Dyno Spectrum, we sell a product called the DS1. The DS1 is its own device that was designed with us and another guy and is built in the US. It's a wireless device, so it connects via a web browser to your phone, to your computer. I mean, some of our early guys did it with their watches, but basically what it does is it's very similar to some other things in that it comes predetermined with off-the-shelf maps. So let's say you have an intake or turbos or whatever. It's got various stages that you can put on, which is great, and it works for a lot of our users. The other thing that we do is that we supply what's called an XDF. So with Tuner Pro, which is something we don't write, but with Tuner Pro, you can drop in this XDF, and this comes with every DS1. You can drop in this XDF, and the XDF is basically, like we were talking before, with definitions. So it gives you all the tables, everything else which you would need to custom tune it. On top of all this, we also offer the super fast logging, real-time tuning. So that was another big thing that was invented by John, and we've really tweaked and got working very well. Is the ECU, there was real-time tuning before. This is different in the fact that you can wirelessly tune a car with, every single table inside of a car from the other room. Even most standalones can't do that, barring needing some other things. But so you can do full real-time tuning, map switching, Flexfuel, custom maps. I don't think there's a more powerful stock ECU tuning device out there, especially one that the end user can make all the changes themselves. They can encrypt the files so they can't be stolen, things like that.
There's a bunch of stuff there to just unpack in a little bit more detail. So particularly from what I've seen through my commercial tuning business, when it comes to the European tuning market, sort of Volkswagen, Audi group vehicles, BMW, Mercedes, etc., there's a lot of products out there that allow flashing and reading of those ECUs, and a lot of them seem to sort of work on the master slave sort of business model, where there'll be a master tuner who's actually doing the hard work of defining the maps, making the changes, testing and validating those changes, maybe on a car in their workshop, hopefully on a car in their workshop. And then they develop a network of slave dealers who are basically getting customers come in the door, and they'll just flash an off-the-shelf map that this master dealer has developed into the customer's car, send them out the door. And I guess the answer there is that for a lot of people that does work, provided that the off-the-shelf maps have been developed. The problem I sort of saw with that model was it didn't really allow those slave dealers to make subtle changes. Maybe you've got a car that's got a modification that's a little unique, and you can't sort of tailor that unless you've got a really good relationship with that master dealer and they're prepared to make those changes for you. The other problem there is a lot of the software that's available, and I won't sort of name names, but it's quite expensive. And when you actually get down to the nitty gritty, you quite often find that particularly for the less popular models, the definitions that are supplied with it are either woefully lacking or sometimes just incorrect. So that kind of leaves the tuner back in the situation where they need to go and find maps. And it was sort of touched on already. I mean, they're very different skill sets, tuning an engine to actually finding maps. So it sounds like your product is essentially covering everything. You've got the ability to just flash in an off-the-shelf map for those who maybe don't have the interest or the knowledge in actually tuning their own vehicle, but for those who want to get really deep into the weeds with this stuff, you're also providing thorough, well documented definitions so that the tuner actually knows what maps to use. Have I sort of covered that off correctly? Yeah.
And the other thing that we kind of John did is, we'll go back to the 96 maps thing. With the switchable maps stuff, a lot of it's also been, I'll call it simplified, so that you only have to make changes to, say, a gasoline or an ethanol map for Flexfuel. Instead of those 96, you're just making a change to 2 maps. Maybe you have to do the minimum tables, but we're really made it so that we try to make it as easy as possible for people, for professional tuners like you and I that do this every day for a living, that, need to tune cars and don't have time to take the time to tune one car in 5 days. It's simplified a lot of that process. And the other nice thing is we don't hide, any of the data. So the OTS maps you can open, the end user can open the OTS maps. They're not locked. They can see what we've changed. They can see what we've done from a calibration perspective. And if they want to change them, great. If they want to change, if it's knocking a little too much, or if, whatever, if they want to raise the idle, whatever they want to do, they can do that. And with complete flexibility, there's nothing that they have to buy extra. There's nothing hidden. It's all there and just ready to go.
Okay. The other aspect that I want to dive into is this real-time tuning, because I know, because I went through this transition myself, coming from a standalone tuning background where you obviously are live tuning every parameter, at least to start with. In the factory engine management world, that just wasn't an option. Live tuning wasn't a thing. We always had to essentially log, then stop the car, look at our log file, decide on what changes were required, apply those to the maps, and then shut the engine off, essentially flash those changes in and try again. Now, that sounds like a chore. The reality is, at least when we're on a dyno and we're doing wide open throttle ramp runs, it's probably actually not too much different to a standalone because we don't tend to make a change to the ignition timing while we're doing a ramp run. What it does do is it dramatically complicates the steady state part throttle tuning where we want to be able to make a change while we're running the engine at, let's say, 3000 RPM and maybe 40% throttle or whatever that may be. Now, as time went on and I sort of spent more time tuning factory engine management systems, we did see some of the open source and commercial reflash manufacturers offering some real-time tuning. And, often that was a case of a handful of select maps that you could real-time tune. I know Cobb, as you kind of alluded to, offer this. And that was a real godsend for a lot of us as well, a huge time saver. You're saying, though, with your solution that every single map is available for real-time tuning. How are you getting around that? How's that possible?
Changing the code and the amount of free RAM are the main things. So, for example, on the Japanese cars, some of the ones I've mentioned, there might be a couple of kilobytes. And so if you're going to select a group of real-time tables, you could fit about 5 or 6 3D tables in and a couple of 2D ones. Some of the ECUs we're dealing with now have 50, 100, 200, 300 kilobytes of free RAM. And that's approaching the size of the calibration on some of the smaller ECUs, but certainly it covers many times over the number of changes you would need to make in a calibration. So, for example, our off-the-shelf maps that are open, we only change things that need to be changed for a defined reason that we can explain, defend, and teach. And so, for example, we may only change 20 kilobytes in a 300, 400 kilobyte of actual calibration data to do a stage 1 or stage 2 type tune. And that's all you really need to change. So in that way, because we allocate at runtime, if you like, which tables are going to be changed, we can do that until you run out of memory. We don't have to pre-select what we're going to do. So there's a couple of cars you have to be a bit careful. And the biggest one actually is the 96 ignition tables because they're often grouped together. And if you consolidate those so that you tell the tuner which one to adjust, you save a lot of RAM by not having to adjust all 96 of them. But we never reduce function in any of the changes that we make. We never reduce safety. We just look at places where tables are the same from the factory. Their function is the same, their purpose is the same, and it makes sense to keep them the same. But then we might consolidate and collapse them so that when you change one of them, we actually label clearly, you change this one, you're changing another 32 of them that you now don't need to touch.
And my broad understanding with this technique, and you sort of mentioned there, the RAM, you're copying essentially, as I understand it, again, these tables into RAM so that they can be changed in real time. But if you power down the ECU at that point, those changes, because they're in RAM, are lost. I believe that's correct. So at the end, once you've actually made your calibration, you still need to flash those permanently into the ECU. Am I on the right track here? I'm completely lost.
You are on the European ECUs. On some of the Japanese ECUs, they keep their RAM when you turn them off. But yeah, generally we flash. But we also, as well as doing real-time tuning, we do a calibration flash on most of our ECUs in 30 seconds. And it's actually about 10 seconds of writing actual data. And the rest of it's waiting for the ECU to erase the segment and connect and go through all the process. So, 30 seconds isn't bad to consolidate things after you've done a real-time session. And if you were to run out of RAM or you want to go to lunch or whatever, we have methods you can either flash it or you can resume your work from where you left off and continue. And we use safety mechanisms to make sure that the tuner knows that they've got the files all in sync and that they know what they're doing. That
30-second flash time seems incredibly fast, just given most of the factory engine management systems I've dealt with so far. I mean, it's not uncommon for flash times to be in the region of sort of 2 or 3 minutes, sometimes multiples of that. Is there something tricky that you're doing to bring that flash time down so quick?
Our own hardware and our own software or firmware that goes in that hardware typically doubles or triples our performance compared with tuners that would buy in hardware which isn't performance optimized. We deliberately make the package as tiny as we can, as fast as we can, and as customized as we can. And, as a startup company where it took me 3 years with no income, we bootstrapped this ourselves. I was developing all these strategies and automations and methods. I wanted to hit the market with something hard that would be worth that 3 years of beans on toast, as we call it in the UK. So that when I hit it, nobody would be able to catch up. And, that's what we tried to achieve.
Now, you've also talked so far multiple times through this interview about custom features. And you're definitely not the only ones offering custom features, but basically by that, I'm talking about something that the ECU from the factory didn't offer. Maybe that's Flexfuel, whatever it may be. How is that possible when you're starting with a factory controller? What's necessary to introduce custom functionality?
You have already compiled code, which you need to understand. And then the usual concept of it is making a thing called a hook in the code, which sends the ECU off into running your own code. So, for example, when an ignition map is looked up, it goes off and runs our code instead, having already looked up the factory ignition map. And that means that we can then do anything we like with the lookup. And that ignition one, for example, is a particularly powerful but also particularly dangerous one if somebody gets it wrong. So you need to be really careful that you don't, say, change the signed variable into an unsigned one and suddenly have 64 degrees more ignition timing than you should, for example. So you have to really be careful and test and keep very focused on what you're doing. But yeah, the principle is to put lots of hooks in the ECU. And I used to do these manually in assembler for every version. And if you're only dealing with, 4 or 5 versions and you're only putting 10 hooks in, that's fine. But we now put in hundreds of versions, and we can't afford to make a mistake because you blow something up, and we've never blown anything up with a code error, and we don't ever want to. And the way we do that is with automation. So part of that 3 years of run up to this, and also to ensure that we were competitive, was that if we want to recompile and rebuild our code, although it's in an already compiled ECU, we can change a line of code and rebuild 30 or 100 versions, let the computer get on with it, let the computer do all the tests and the checks to make sure there are no errors, and then release an update with a new feature or occasionally an improvement or a fix.
I guess when you're working across so many different software versions, that would just absolutely be an essential element. There's just no way one person could do that to all of those versions in a time-efficient manner, correct?
Yes.
With the ability to add this sort of functionality, is it really a case of the sky's the limit? Are the limitations on what features you can add to a factory controller, or is it just a case of what a customer is requesting and what you can dream up?
Not really. I don't think there are any limitations because these ECUs have enough processing power considering the temperature rated for under hood use next to the engine. They've got enough memory. Code is small. New maps are relatively small. Really, it is usually imagination. We do occasionally get constrained with the amount of free memory, but for example, I've measured that the impact of all of our patches on processing time is less than 1%. So the ECU has plenty of power left, and we still have, like a megabyte of free flash, yet we might only have 100 or 200 kilobytes of our own code to do some really pretty complex stuff. So it's not so much the machine resources, it's more the human resources and the imagination, but also the commercial relevance of it. But as well as us writing the patches, I've been doing that now for 16 years since I started doing it on the Evo. What we've tried to do in the last year and a half is to now give that facility so that customers can write their own. So now we can let skilled tuners who would often need help with this, but they can actually write their own code in C to patch the ECU, and they can actually even do that whilst the engine's running, using our real-time strategies. And that needs care, because if you write some bad code, the ECU will reset. So, we put all kinds of warnings on this and about how it's tested, but this is really a segue into what we're doing with the V10, R8 and Hurricane stuff, because it's a normally aspirated, expensive very high revving engine with high compression that has immense tuning potential, for which people have been using standalones. And our whole mission has been, well, why not use the ECUs that are in the car? Because they are in some ways more powerful than most standalones. And the biggest element is understanding them, utilizing them, and doing it all correctly. And I don't really see many limits apart from what people can imagine and actually find the commercial relevance and funding to achieve. And thankfully on high-end cars where we like to help, people are enthusiastic enough to fund the more extreme end of this sort of activity.
So also to touch on that a little bit, a lot of what, we've talked about custom features and everything else. A lot of what has been added in the past year and a half is what we would call custom maps. So with the custom maps, you can drop in C code. We have guides on how to do, custom boost control. It basically allows you to do kind of whatever you want to do. Andre, you might kind of appreciate this. So in the old gold box, like M800s, do you remember how you could kind of change axes and things like that?
Yeah, very powerful.
Right. So this can do that exact same thing. So you can populate your X and Y and Z data all from, let's say, a custom input. Let's say you want to bring in a map sensor, a temperature sensor, whatever. If you want to bring something into the ECU, we enable you to do that through the powertrain CAN bus. So you can bring that in, put that into these custom maps, and then even to the point that it can only work in certain maps. It can be used as safeties. So if you go over a pressure limit or a temperature limit, it can drop to a certain map for safety. The sky is kind of the limit on what you can do in terms of that. And the nice thing about that is there is a bit of a learning curve to get that to work. Once you have that, it is really, really, really powerful because you can add just about anything you can think of.
I'm glad you just mentioned that, Mitch, about bringing in additional sensors over the CAN bus, because obviously, some of the control strategies we may want to implement, Flexfuel, for example, on vehicles that have no Flexfuel sensor, you may need to actually bring in some additional inputs. And obviously, on face value, we're limited by the I/O that the factory engine management system has. And back in the early days, maybe we've talked about Subaru, Mitsubishi already. It was possible to bring in a sensor over maybe the rear O2 sensor wiring. So basically physically wire that into what was the rear O2 sensor input and bring in a wideband, for example, or something of that nature. So now we don't need to do any wiring. The ECU doesn't get touched. You've got the ability to bring in these sensors, and I'm assuming it's going to require a module to convert an analog voltage input into a CAN message. Is that something you're offering there?
We don't sell those devices. We just integrate with them, but we have used and tested a lot of them, pretty much all of them that we know of, more or less. But no, we don't sell them. We do try and support as many as we can in terms of helping customers if they need support on our side. But yeah, it does give you the ability to wire into the powertrain CAN and add. I mean, even to the point, like I know you've had Sander on here. Sander's a good friend of mine. I mean, we even brought an INS onto the factory CAN bus just to show we could do it type thing. But we did bring in the INS over the stock powertrain CAN, and based on that, we could take it and make control strategies based on, something even as complicated as the INS.
Yeah, okay. It does really open up just about unlimited possibilities, but it also begs the question of the skill set that is required to make use of this. And you've already mentioned there, you can the user can potentially write their own code in C. And that's, again, sort of comes back to this quite markedly different skill set from actually tuning an engine. I mean, most tuners probably haven't come from a computer programming background. No doubt there's a handful that will have, but I think that's the exception, not the norm. So, let's say we've got a commercial tuner who's pretty smart, pretty intelligent, wants to expand their skill set. They're very competent tuning factory and aftermarket engine management systems. They come across your system and the light bulb goes off in their head and they want to start start expanding what they can do by writing this custom code. I mean, at that point in their career, is learning enough in programming with C possible, or is that sort of a really dramatic departure?
It's quite difficult, I would say. And we did this because we wanted the features, particularly on the V10, for a boost controller. So we knew that not a lot of people would use it. It's a handful at most, and then probably only 2 or 3 that really use it to its potential. And it's great to see them do that. What we've done, we've made these open examples again, but rather than people having to build them themselves, we do actually then just give them a file on the DS1 for the V10s that has the boost controller code in it with some sample tables. So in a lot of cases, it's nice that people can look under the hood and understand what we've done and learn from it. And I don't know of anyone yet that's actually rewritten our closed loop boost controller because the code isn't there on the normal aspirated engine. But, it's there for them to learn and to think about. Maybe they will soon.
And the other thing I would say is with the custom apps, there is C code you can drop in. You can also you can basically populate some data values, and we give you a sheet on the DS1 that will tell you where these RAM addresses are. So you can populate tables yourself, as a tuner, and make like engine safeties, things like that. So that part of it is a little easier. I would say that's actually tremendously easier. So it's a lot easier for a commercial tuner to wrap their head around something like that. A full build in C of a closed loop system is a lot more intense. But again, you can kind of take both ways. You can go really far into it, or you can kind of pick the things that you want to do, make your safeties and do that kind of thing. And it still allows you to do all that. So it's kind of both ends of the spectrum, so to speak.
Yeah, I mean, it sounds like we're getting to some fairly sort of niche requirements where that is something that the tuner is going to be using. But I mean, the fact that you've incorporated that and they can, I mean, that's amazing. We've talked here a little bit about this Audi R8, and obviously that shares the sort of platform with the Lamborghini Huracan. That's become an incredibly popular platform, particularly in the drag racing and sort of roll racing area. Particularly when you start adding a couple of turbos to these vehicles, it seems like they really come alive. And it's a platform that's well supported now by the likes of Motec and Cyvex with full aftermarket standalones. So I'm interested here, what is the sort of benefits to going standalone? Is there any benefit? Are people only going standalone because it's what they know and understand? Can you essentially get the same exact results using your DS1 product with the factory controller?
There's always, people always kind of have preferences on what they want to tune. Even if you wanted to say, I've got a V10 car, I'm going to go standalone, is it Cyvex or Motec, and people argue till they're blue in the face about which one's better. It still kind of comes down to preference. There's always going to be the guys that want to use things like Motecs because it might be a little bit easier for them. They might be more familiar. With the DS1, it really does have the ability to do a lot. I would say it checks the boxes of pretty much everything a standalone can do. The only really kind of quote unquote downside to it is that it is a little bit more complicated. It takes a little bit more time to learn. There are some other gotchas like logging, in-car logging, but that is something that potentially will go away. But for the most part, they're honestly more similar than you would think. I don't know if you've done much like Bosch motorsport stuff, but really kind of what the DS1 has turned the Bosch ECUs into is a pretty similar form of the Bosch motorsports ECU. It's even the naming conventions are the same in a lot of the engine speed and things like that. So it's very, very relevant, especially if you are. It sounds strange to say you're on a budget, but some guys don't want to spend that much money on a standalone, and this is a good option for them, especially if they want to stay at a reasonable horsepower of 14 or 1500 and not go the whole 2,000-3,000 route. It's everybody's, like I said, everybody's got their preference, but this is a good option for a lot of folks. So.
It's sorry for laughing there, but when you use 1400 as a mile power level in the same sentence, it's just makes me realize how far things have come. The budget aspect, I was going to bring that up and then wondered if it becomes a bit of a moot point when you're talking about a car with a sticker price that's probably, I mean, I'm not shopping for them, so I don't know, but probably well over $200,000. You know, that being said, everyone still does have a budget. I'm assuming that your DS1 product is going to be fractions of the cost of a standalone for the likes of an R8 or Huracan.
Yeah, it's about, so we charge $25.99 full retail for ours. And I don't know Motec pricing, but I want to say it's closer to 15 to 20,000-ish.
Yeah, that's a significant difference.
Of course, you need 2 ECUs on the V10 as well, because even the standalone ECUs just don't have enough outputs to cover, 20 fuel injectors.
Yeah. If it's these engines run direct injection with port injection as well, so a 10-cylinder engine, you've got 20 injectors, correct?
Yeah, you need like all the I/O you can get.
Yeah, okay. Now, you mentioned logging, and that's one of the aspects where, I mean, the line as I see it between at which point you need to go standalone is constantly becoming more and more blurred. And I don't think there really is a black and white anymore. But one of the things that has always sort of pushed me towards this is the time for a standalone is when you're in a motorsport application and you want logging, because traditionally, particularly onboard logging with a factory engine management system, it just hasn't been a thing. I'm assuming, though, given the vast changes that you're making to the logging capability, is it possible then to provide that output into a central hub logging device, maybe a dash logger or something of that nature?
Indeed it is, and it already exists. There's a third-party product that works uniquely with the DS1 called BT Res, which started as a nice widescreen color display on which you can put gauges, and they're beautiful, and it's a fraction of the cost of similar devices. But it has gigabytes of storage, and it continuously logs, and it automatically uploads those logs to the cloud, and then they've got their own viewer that you can view it in. And I think he's about to, or just has released a headless version that doesn't have the display. And, when you start looking at using, system on modules with, eMMC chips with gigabytes of data, suddenly this disadvantage when you're using almost commodity hardware wrapped up in some nice software, for $500, you've suddenly moved the goalposts rather more than the standalones can do.
Yeah, absolutely. Now, one thing just to circle well back here, we haven't really sort of talked about the range of vehicles that Dyno Spectrum are supporting with this DS1 product. Obviously, we've dived into the R8 platform there, but what sort of, for those listening, what sort of range of vehicles can you provide support for?
At the moment, we started with the Audi 4-litre, so that would be about the 2012 to 2018 models. So that's things like the Audi S6, S7, RS6, RS7, S8, A8. And that was a fairly niche car, and we started with that because I had one and I liked it. And we also thought it would be small enough that we could support it well and we could go deep on a product and really show what we could do. And that has surprised us because I think we've probably changed that into a bit of a tuner car for those that know. It's certainly a bit of a sleeper, something like the S8 that comes with 600 horsepower or, say a 520 horsepower model, you just reflash it and you had 150 horsepower. You add some ethanol to it, you add another 100 horsepower, you change the turbos, and the stock internals and engine will do 1,000 horsepower. So that was an incredible car. We've really enjoyed turning that market around, and that's really what got our foot in the door as Dyno Spectrum. The next one we did was the Audi RS3 and the TT-RS. We came quite late into that market and it already had standalones. So we've made an impact there, but the R8 and the Huracan has been really quite a special one, not because of volumes, but because it's encouraged us to just push on and really push as hard as we could and do things we only dreamed of technically, even if they're probably not that commercially relevant, but they've been fun. I think where we're going next is we're going to try and go a bit broader. And we're going to really focus on what features we need to offer and select the cars a bit more. But we're going to go wider in the VAG group, certainly. And see if we can do more of the good flashing at home stuff for more people at, perhaps a slightly sharper price point without all the features, and then add the features in for the really special cars, the tuner cars.
Just from a business perspective, I'm interested in your sort of thought process as you were forming Dyno Spectrum. I mean, John, you've mentioned you sort of beavered away eating ramen noodles or beans on toast for 3 years with really no kind of proof of concept, I guess, of what the finished product was going to sell like. Was it just a complete leap of faith, or you knew that if you built it, that the customers would come? Had you done any sort of business sort of planning strategies? Give me a bit of insight into that side of things.
Two elements, really. I suppose I had done it before open source on the Evo, and then the proof of the commercial reality of this was doing the GTR for Cobb. And, that car was released during a great recession, and it did very well. I think anyone that touched the GTR has done well. But I think being involved in that project, we realized there was a good commercial product to be had from doing really high-end features and looking after customers really well, and also stopping all the secrecy around Euro tuning and really trying to open it up and improve the quality of everything. And so there was a leap of faith in doing it ourselves. I suppose the other element is the beans on toast thing, and the fact that I had a medical career, and in Scotland it's not as lucrative as you might imagine, but I'm a keen saver, and I suppose at the point where I was fed up finally with medicine, I could leave. We'd saved enough, and my wife had set up a business that kept us going. And whilst Mitch says he joined what I did, in some ways I joined what he did, because he had started his own tuning arm as something he was permitted by Cobb to do whilst he was there. And that achieved quite considerable commercial success. And having him on the US side of the pond and me here, and the technical stuff I'd done and he'd done, and the commercial stuff he brought to it, it was by no means a dead cert, but, it
had some confidence
beyond what we expected. Yeah. We had the elements there. It wasn't my first time in business. It wasn't Mitch's first time in business. We were always super lean on things. We never had outside investors. Whilst we've indulged ourselves in doing kind of technical fripperies and sometimes crazy things that people really don't need just for the fun of it, or to say, yeah, we can do it. We do have at base a core of making a good commercial company. And, it's probably no surprise that we've had a number of people approaching us to buy the business, but we're having so much fun that we're not even really seriously thinking of that. We're having the time of our lives trying to turn this market around, and we can't really talk in detail about what the next product is because we want it to be a real surprise, but it's going to be completely different, and it's going to astonish quite a lot of people what it does.
Okay, sounds interesting. A bit of a tease there. Now, Mitch, just again on the business front here, just from your perspective, and I mean this is irrespective of what business you're potentially looking to start up. It's always a very scary prospect when you've got a steady employment. And in this case, I'm guessing at that time you were working for Cobb, and John's just mentioned you were doing sideline tuning as well. At what point do you sort of go, hey, I'm going to take a leap of faith here, throw this career, throw this job away and hope that I can make it on my own? How did that thought process go for you?
John and I had been working on some stuff. A friend of mine had bought a McLaren, so I started doing McLarens, and it was just kind of, it was for fun to learn something new. I really enjoyed my time at Cobb. I learned a lot. I worked with a lot of great people. I got to kind of a point, I was there for 7 or 8 years, and I kind of got to a point where I just wanted to try something on my own. We had built the Porsche Access Port to be quite profitable. And I was confident that we could build another device and something that was a bit different and had more technology in it. And I was just confident in the process, and I was confident in kind of what I had done and what John had done. So it was, for me, it wasn't too big of a leap of faith. It just kind of felt like the right thing to do in the right time.
Perfect. Okay. In terms of the business as it stands, is it the two of you, or have you got other employees working on this? I mean, it sounds to me like being able to develop on multiple platforms. I mean, John, you've mentioned that you sort of wanted to focus on one platform and know it really in depth, intricately, which obviously makes a lot of sense. But to be able to multiply that across multiple platforms, obviously that takes manpower. Have you got other people involved? If not, are you going to have other people involved?
We do. We have administrative directors who happen to be our wives, and that's been very good to keep us going. But we also have a number of contractors that we've worked with, because we've still got the lean startup mentality, and because we want to keep everyone and us keen and everyone right, we have used contractors rather than employees. It's quite difficult to find employees with the right qualities in this industry, and there's a huge skill shortage, and I have to be honest, sometimes an attitude shortage as well in terms of work ethic. I think I didn't used to drive my employees mad when I did have them in other businesses, because it was very defined what they did, like practice managers, receptionists, and so on. But in this, I think I might not be the easiest to work for.
Fair enough. I do echo your thoughts there, though. I think almost across any industry, it is difficult to find good talent. So when you do find those who are good at what they do, it's also really important to reward and hold on to them. Okay, I think we've probably taken up enough of your time, and I do want to respect your time. So I think we'll move towards wrapping this up. And we've got the same three questions that we ask all of our guests at the end. The first of those, which, John, maybe you've alluded to, but let's see what we can talk about. What's next and in the future for you, either personally or you and Dyno Spectrum? And either of you can answer that one.
It's, one of the things we've been doing, it's not a secret, is we've been working on the DS1 for the 4-liter, the RS6, so the new 4 liters, so the C8 platform. So that's coming. We've got those flashing. So the new MG1 ECUs, the newer Bosch style ECUs. So that'll be good for a lot of people, and we're looking forward to that. On top of that, John is moving. Yeah.
We're relocating from Scotland to the Isle of Man shortly. We like it there, but it gives us a chance to be a bit more competitive as well. It's a bit more business friendly, and it's certainly very motorsport friendly, and the roads and the scenery are just to die for. The whole place is basically a TT or motorcycle racetrack. They've got black and white curbstones down the main road. Great place.
The scenery, as I understand it, literally at least once a year is to die for with the Isle of Man TT, unfortunately. An insane event. That actually, I should have asked already, does that create, obviously at the moment we're interviewing you both in Scotland, but that's the exception, not the norm. Mitch, you're normally in Southern California, as I understand it. So talk to us just briefly there about the complexities of working across two very different countries and different time zones.
It actually works quite well, especially for our customers, because they kind of get 24-hour support usually. But yeah, we stay in contact, and honestly, it actually works really well. We don't have really any issue with it at all. Fortunately, John's an insane workaholic, and I'm pretty close behind him, so it works well, honestly.
All right, so this next question, I'll get an answer from each of you. The question is, what advice, if any, would you give to a younger version of yourself to help fast track your career or reach essentially where you are in your career today? So let's start with you, John.
There's a number of things that your previous participants and many people have already said before, and so this is going to be a repeated one. So I would say do something you love. It really does matter, because to me, I didn't for many years. I performed and did my duty, and people liked what I did, but I didn't enjoy my job. And, in the end, it resulted in burnout, and that forced my hand to think about what I was going to do and do what I should have done at the beginning. Obviously, though, with the caveat that you have to do something that people want, that is legal. You have to look after people, treat them right, and all that kind of stuff that makes a good business. And unfortunately, many of those things are not covered by businesses. A lot of people in this industry are not always treated right, and things are not always done to the highest standards.
I could not agree more on all of that. I mean, first of all, you're going to spend the majority of your life in employment. So, you need to be doing something that you're passionate about and enjoy. And I mean, unfortunately, I think it's safe to say the majority of people don't fall into that. So if you've got the option to sort of curate a career from the get-go, then trying your hardest to find something you're passionate about that also can put money in your bank is the way. I think that's something that is really easy to overlook. And I mean, in terms of the automotive industry in particular, I spent 13 years running a performance workshop. I saw the good, the bad, and the ugly. And unfortunately, there's more ugly than there is good. There's a lot of people who simply don't understand what they're doing, and that the results are exactly what you'd expect, which essentially is why we founded High Performance Academy. One of our goals was to improve the level of knowledge and professionalism in the automotive industry. So, that's something that still drives us to this day. All right, Mitch, what have you got for us on that front?
Don't become a doctor.
It does sound potentially not becoming a doctor could have fast-tracked John's career quite dramatically, but that maybe goes without saying.
No, it was good, but it's the same sentiments. It's this industry can be very, very toxic. It can be very amazing too. There's a lot of camaraderie even between shops and things, which is awesome. But that's the same sentiment is do something you're passionate about and not something that you're either forced into or your parents think you need to do. I don't know. I didn't go to college. I'm very happy I didn't. I just think that there's something out there for everybody, and for them to follow that and not necessarily listen to what society has to say they have to do or shouldn't do. So that's probably my 2 cents on that one.
I think probably just to circle back to John's career as a doctor as well, and it's probably a perfect sort of example that don't feel like that's you for life. It's never too late to pivot, and in John's case, obviously a total 180 in career direction, and look how that's working out. Obviously, far happier for that change. So I think too many people probably think that they've made their decision, they've got that sunk cost fallacy of the time and the money they've invested into a career, and that's them for life. But it doesn't have to be. All right, enough dwelling on that though. Let's move on. And if people want to follow you guys and see what you're up to, how are they best to do so?
Social media is our best outlets. We do have our website, www.dynospectrum.com. We have our Facebook at Dyno Spectrum, and on Facebook we have actually a bunch of great resources in Facebook groups. So we have some DS1 groups for the cars we support. There's actually a lot of information, a lot of knowledge in there, a great group of a lot of people in there. And then, of course, we've got our Instagram at Dyno Spectrum.
Perfect. All right. We'll put a link to those in the show notes as well, so people can find those a little bit easier. All right, John and Mitch, thank you so much for your time. It's been really interesting learning about your journey and the products you're supplying. We really look forward to seeing what comes of Dyno Spectrum in the future. So thanks again for your time.
Thank you.
Yeah, thank you.
If you enjoyed this episode of Tuned In with John and Mitch from Dyno Spectrum, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking out a random reviewer and sending them an HPA t-shirt free anywhere in the world. Also, this is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Rob Rickson, who has said, "This has quickly become the best automotive podcast available, which is no surprise considering the standard of HP Academy content generally. If you're just finding out about it, the Shane T and John Reed episodes are treasure troves." Oh, thanks for that feedback, Rob, and we're glad that you are enjoying the podcast. Now, Rob has also asked a question. His question being, what's the best wideband controller on the market, be it integrated in an ECU or as a standalone controller? I've gone with a Spartan for a Link G4X build. Oh, It's a bit of a difficult question to answer. I don't think it's a black and white answer. There isn't one wideband controller to rule them all, so to speak. Anyone who's followed us for a while will know that I'm a huge fan of CAN-based wideband controllers. The reason being that this ensures the integrity of the data being transferred to the ECU, meaning that we can trust the numbers we're seeing. Having said that, if you've got an ECU that does offer an onboard Lambda controller, I would 100% be using that because it's going to save you some money. Specifically with your Link G4X example, I probably would have recommended that you go with Link's specific CAN-based controller, their Link CAN Lambda unit. Now, the reason for that is it gives you the advantages I just spoke about, but there is actually a two-way communication with the Link and its CAN controller over the CAN network, meaning that diagnostic data is being sent to the ECU. The ECU will also send RPM across to the CAN controller, the Lambda controller, I should say, meaning that it won't run the heater element in the Lambda sensor until the engine is running. And this can really extend your sensor life. Now, if you've already spent your money on the Spartan controller, no big deal, nothing wrong with that, but just some information for the future. Anyway, Rob, thanks again for your comments there. Get in touch with the team with your t-shirt size and shipping details, and we'll fire a fresh tee straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpaacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpaacademy.com/courses.